All right, friends. So, probably the most important of all the systems lessons here. So this will pretty much allow us to solve any system, at least any two variable and three variable as well, if you understand the concept well enough. So let's just do a quick refresher of the last lesson. Right, the last lesson was the addition method kind of failed, but you had the same terms, right? Like I don't have opposites like what I really want, right? That was like our layup system. But if I have the same term, I just want one of them to be negative and one of them to be positive. So we said we can multiply by -1, and that's going to have the effect of doing just that, right? It's going to make the -3y positive 3y. So what now I can do is now I can add them. So everything we're going to do today here is going to be rooted in the addition method, right? How can I create opposite coefficients of the same variable? Because then that's going to happen, right? When we add them together, we get a sum of 0, right? They eliminate. So I get 3x is equal to 18, right? So x is 6. And another consistent theme is that solving for the other variable is going to be a little bit more time intensive. I mean, it's a two-step equation at the end of the day, but just thinking back to what we did with the substitution method, that was always a much simpler method to solve for the second variable. But we'll get there, right? So I get -3y is equal to 12. Right, so it looks like y, -12, positive 12. So it looks like y is going to be equal to -4. So I seem to be looking at 6, -4 here. Quick check of the first one, I get 12 plus 12 is 24. Quick check of the second one, I get 30 plus 12 is 42. All right, now, of course, the question then becomes, what happens if the addition and the quote-unquote subtraction methods don't work? Right, so adding these is not going to help. Multiplying one of them by -1 is not going to help. So obviously, if we can multiply by -1, we can multiply by something else. So I'm going to do this one two different ways, right? We're going to eliminate x, we're going to eliminate y. So if I want to eliminate x, I want the second equation to have -2x, right? That way I can add that with the 2x, I can eliminate x. Well, that should be pretty easy. All I need to do is multiply the second equation by -2, right? That's going to give me -2x. It's going to give me -6y. It's going to give me -20. I need to then bring this equation down. I'm just going to rewrite it. I'm not doing anything with it. But I can tell right now that adding these together will, in fact, eliminate x. I get -5y equals -15. Right? So I get y is equal to 3. I'm going to use, let's use the first equation, 2x plus y equals 5, right? So y is equal to 3, so it should be pretty evident that x is going to be equal to 1. Right? So my solution should then be 1, 3. Checking the first one, 2 plus 3 is 5. Checking the second one, 1 plus 9 is 10. Would it have been just as easy to eliminate y? Well, sure, right? So here we want, we want 3y. I want -3y. So I'm going to multiply by -3. So -6x, -3y, -15. So now when we add these together, as we'd expect, we eliminate y. -5x equals -5. Right, sorry, so x is equal to 1. And we know how this goes, right? If 1 plus 3y is equal to 10, then y is 3. Right? So once again, we get 1, 3. So we can go back and check and we get the same results, right? Okay. So we're always trying to set up the addition method, right? We want to create these opposites that we saw here. Right? Now sometimes it's easy and sometimes it's a little bit less easy. So these would be the steps. Again, if you're someone that likes taking some notes, I like this because this is not a word we see super frequently in math, right? Decide. Right, like if we're learning the standard algorithm for, division with decimals or multiplying 2-digit numbers or something, it's you do this and then you do that and then you do that, right? We don't make a lot of decisions, right? We're all going to kind of do it the same way. But I like systems because you kind of have an infinite number of ways that we can do this, right? Like I didn't have to multiply by -3, right? I could have multiplied the first equation by 10 and the second one by -20, right? Now, would there be value in that? Maybe not, right? I could have used substitution. I could have divided the first equation by -2, and it would have got me -x, and then -half y, and -5 halves. So when we really think about it, systems are really cool because there's so many different strategies and different methods if we want to think outside the box a little bit. And speaking of that, right, so here there's a clear variable that's going to be easier for me to solve for, right? Like, could I eliminate x? Sure, I could eliminate x, right? We could multiply both equations, which is something we'll have to do a little bit later. I can multiply by a fraction, right? So if you want to be really savvy, multiply negative 2/3. Now, I don't think you want to take negative 2/3 of 16, but if I take negative 2/3, at least with the x, it's going to give me negative 2x. Alternatively, I can multiply by 3/2, or negative 3/2, right? That's going to give me negative 3x. It's going to give me, 6y, and it's going to give me negative 9. So that's not horrible to do, not necessarily what I'm going to do, but it's not the worst thing in the world. So if you want to think about using fractions instead of, sometimes multiplying two equations, but the obvious thing here is to multiply the first equation by 4, and that'll allow us to eliminate y, right? Because what's going to happen is, right, our whole goal is to create opposite coefficients of either variable. In general, which one's going to be easiest for us? So again, eliminating x here is going to be problematic. Either we're going to need two multiplications, which we'll eventually have to do, or we need to use a fraction. But this is going to be pretty easy, right? If 14x is equal to 70, x is 5. And it's going to be easier to use the first equation, 1, because everything is positive, and 2, because the coefficient of y is 1, so it saves ourselves a step at the end. So I get 15 plus y is equal to 16. I get y is equal to 1. Right, so I end up with 5, 1. Checking the first one, right, 15 plus 1 is 16. Checking the second one, 10 minus 4 is 6. All right, so now we have one with A and B. So I'd say both of these are going to be same level of difficulty, right? If I want to eliminate A, I'd use negative 3. I'm going to eliminate B instead, right? So one thing that we're going to see is you should never have to multiply, well, I'll save that for when we multiply two of them, but I'll say now, if you're multiplying both equations, you should never have to multiply both of them by a negative number. Anyway, so for now, I want to eliminate, let's say, B. So since the B term here is already negative and the B term here is already positive, I can use just a positive number, right? Because that's going to give me 9A. It's going to give me the negative 3b. Let me just get rid of that. That was kind of confusing before. Minus 3b, and it's going to give me the 9. Right? So now when I add these together, right, we eliminate b. I get 10a is equal to 20. So obviously a is going to be equal to 2. Right? And I'm going to use probably the second equation. Again, makes no difference. I'm always going to try to defer, just so you get in the habit of doing it as well, to the one that's easier. But you can always use either one. They'll both work. Right, so 3b equals 9, so b is equal to 3. Now, I'm not going to write this as an ordered pair. Right? There's nothing that explicitly states, right, if I say 2, 3, that somebody that's scoring a test or a Regents or whatever is going to understand that that means A and B, because there's no coordinate plane with A and B unless you label it that way. So I'm just going to kind of box it up like that. Unless you want to say something like, well, with the ordered, you want to do something like that, go for it. But I think it's better probably just that we box it up. All right, so I was about to say, hey, we're going to need to use that two-step elimination. But if we're savvy, we realize that 2 is a factor of 6, right? So sometimes my students will say things like, we can make 2 into 6. And what they mean is 2 is a factor of 6, or 6 is a multiple of 2, right? With the y, I would need to use either 3/5 or 5/3, depending on which one I was multiplying. We probably don't want to do that. Now, alternatively, right, sometimes we look at this and we say, well, I can simplify this. I can make this into 2x plus y is equal to 9. So sometimes we have coefficients that are all have a common factor, and I can divide. And is that going to make things easier? Well, maybe, right? Because now I can multiply by -1 or subtract or whatever our method is. So not necessarily the route I'm going to go here, but just something to think about, right? In the interest of thinking outside the box. And this should allow me pretty easily to eliminate x, right? Again, eliminating y is going to be difficult. You would need to use a fraction or double multiplication. Now, we try to avoid double multiplication unless we have to. Now, oftentimes, once students learn it, they want to use it for everything, and we'll talk about that in a little bit. So we get 18y is equal to 90, right? So y is equal to 5. That doesn't really make any difference here, right? If I'm going to be negative phobic, I will use the second one, though it really makes no difference. Again, this is going to be a little bit more time consuming than with the substitution because we actually do need to solve the two-step equation, right? So I'm going to move the 15 and get 6x is 12 and x is 2, save myself some time here. So we should get 2 comma 5. Right, checking the first one, I get 4 minus 25 is negative 21. Checking the second one, I get 12 plus 15 is 27. All right, all fine and good until we see something like this, right? So if I'm going to eliminate x in one step, I would need a fraction, right? 2/3 or 3/2. Same deal for y, right? I would need 2/5 or 5/2. So what are we going to do? We're going to multiply both of them. Now, sometimes there's a lot of ways we can think about this, right? So sometimes I'll say, well, let's say we want to eliminate x, right? What's the least common multiple, right? It's 6. So I'm going to put my targets on the side. Now, I don't care which one is negative, right? Since the coefficients of 3x and 2x are both positive, it makes no difference. Now, if one of them was already negative, well, then I would definitely want to make this one negative and this one positive. And this goes back to what I said a few minutes ago, which is that you should never have to multiply two equations by negative numbers. If 2 negative numbers works, then 2 positive numbers would work. So if I've got 3x and I want 6x, I'm going to do 2, and here I'm going to do negative 3. Now, if you don't know what the LCM is, you can always switch the coefficients and just make sure one product is positive. And we'll see that a little bit later. All right, so this is what it's going to look like. Here's my second equation. And this should resolve really easily and simply here, right? Obviously, our goal was to eliminate x. We accomplished that goal. We get y is 1. It doesn't really make a huge difference. I'm just going to grab the first one, right? 3x plus 2y. Right, we've got that y is 1. Right, pretty simple two-step equation, right? Add negative 2, divide by 3, I get x is 5. Sorry, I'm cutting down the steps just to make these videos not excruciatingly long. We get 5, 1. I check the first one, 15 plus 2 is 17. I check the second one, 10 plus 5 is equal to 15. And just like I did earlier, I'm going to solve it using both methods. So I'm going to eliminate y now. So here's the method, right? Like, obviously 2 and 5, you know, the LCM is going to be the product. But let's say we didn't know that. We switch the coefficients and we say, well, right now, if I multiply this, both of the y's are going to be positive, so I make one of them negative. I'm going to make the first one negative for no particular reason. So I get negative 15x, I get negative 10y, I get negative 85, I get 4x, I get positive 10y, I get 30. And we're going to add these together. And as predicted, the y term eliminates. Negative 11x equals negative 55. Right, so generally with two-step elimination, it doesn't make a huge difference if, you know, which variable you eliminate, just because you're going to have to multiply them both anyway. So the first thing we would generally do is say, can I do this in one step, right? Is there a way I can do this in one multiplication instead of two? Now, sometimes when students get so accustomed to the switching the coefficients method I just showed you, they just want to do that all the time, and that's okay. But if we're thinking about efficiency here, right, I'm going to think about always, can I do this in one step without having to necessarily use fractions, right? I don't want to use 2/3 of 17. I don't want 5/2 of 15, right? So I could do it that way, or 2/5 of 15. I guess we could do 2/5 of 15. Anyway, so we get 5, 1. So, right, again, the only little wrinkle here I added is you got to multiply both equations, right? So each. All right, so we have a lot of choices. I could eliminate x. I could eliminate y. I can use, you know, really if I wanted to, so I'm going to say, let me eliminate y. And the reason I'm going to eliminate y is because my coefficients already have opposite signs. So if I'm switching the 5 and the 3, right, whereas before, right, I modeled this, I said I switched the 5 and the 2, right, which is what I did here, and I made one of them negative. And I said I made one of them negative because if I just switched the 5 and the 2, both of these terms would be positive. That's not going to eliminate using addition. Right, but here I'm going to say, well, I've already got a negative term here. So I'm cool with multiplying by 5 and 3 because I'm going to keep the negative negative, I'm going to keep the positive positive, and then everything should be good. right? Could I multiply by 50 and 30, or 500 and 300, or 10 and 6? Yeah, there's an infinite number of ways I can do this. All of those are going to give me a common multiple. If I multiply by 50 and 30, it's going to give me negative 150y and 150y. Now, is there value in that? Not really. But if you did have fractional coefficients, right, which maybe we'll look at a later date, then we may want to think about doing things like that, right, depending on the complexity of the system. Right, but for something like this should work pretty easily. Right, so I should be able to tell that we were successful because I eliminate y there. If 31x is equal to 62, then we should get x is equal to 2 pretty easily. All right, let's see what I want to do. Let's use the first one, right? Who's negative phobic here? Not us, right? So I'm going to substitute 2 for x. And should be pretty simple, right? If 10 minus 3y equals 7, negative 3y equals negative 3, we should get y is 1. And of course, that would make my answer 2, 1. Checking the first one, I get 10 minus 3 is 7. Checking the second one, I get 4 plus 5 is 9. Yes, I could have multiplied by 2 and negative 5, or negative 2 and positive 5, and eliminated x, but we chose to eliminate y because we already had opposite signs. All right, so for this one, I'm going to think about the fact that both coefficients in the first one are negative, both of the second one are positive. So whatever variable I eliminate, I'm going to be able to multiply both positive numbers. So let's do x, right? So I'm going to switch the 7 and the 2. And I'm cool with leaving it like that because I can tell right away that I'm going to get negative 14x for the first one and 14x for the second one. So I get negative 14x, right? I get negative 21y. I get 77. I get positive 14x. I get positive 4y. I get negative 26. And again, we know that we were going to eliminate x here. So I'm looking at negative 17y is equal to what? Wow. 51. I apologize. I don't know why that took me so long. So I get y is equal to negative 3. I'm going to use the first one here. Apparently my brain's not working so well, so those negatives may give me a tough time here. So let's use negative 3 here for y. All right, so I get 7x minus 6 equals negative 13. Adding 6 on both sides tells me that 7x is equal to negative 7, so x is equal to negative 1. And I certainly better check here because I don't want to make another mistake there or a near mistake. So the first equation, I'm going to get 2 plus 9 is 11. That one looks good. The second one, I'm going to get negative 7 minus 6 is negative 13. All right, so almost under 18 minutes, we did our whole elimination method. So now we should be able to solve any system, right? If we're asked to do it graphically, fantastic, we'll graph. If not, if I have x equals or y equals, substitution. If not, we're going to try to set up the addition method. And the way we do that is by multiplying either one or both of the equations by the appropriate number. That will allow us to add opposites and eliminate that variable, and then we can solve for the remaining variable. So hopefully learn something pretty important here today. Next thing we're going to look at is going to be there's so many different types of word problems that we can write and solve a system for. And that's really why we do this, right? In a vacuum, there's not necessarily a purpose in solving something like this. I guess it would be cool, but there's so many different types of word problems that honestly, without algebra, we just wouldn't be able to do. So that's kind of the worth of doing this. So I'm going to stop talking now, and hopefully you guys come back and watch the videos on word problem systems.